As you can see from what's up on the board here, this tutorial is just a little bit of additional practice with doing mole conversions and gram conversions so that you can see a couple of the more complicated type of bracket problems that we may see in this chapter. I have 4 different problems listed up here. Some of them are 1-step, some of them are 2-step. One thing I'm going to add up here that may help you is a little device that students in the past have used to help remember how many steps a problem should be. And it looks something like this. In the center it has moles, on the far left it has grams, and on the far right it has atoms and molecules. The whole idea behind how this little device works is if 2 things are right next to each other, for instance grams and moles, that means I can do it in 1 step. I can do it in 1 set of brackets. If 2 things are more than 1 step apart, right, grams and atoms for instance, it means I have to do it in multiple steps, and furthermore, it tells me what unit I should change it into in between, grams to moles, moles to atoms. Eventually we'll evolve into adding 1 additional step where we will find atoms of a molecule, but those are at the very end. For now we're just going to tackle these ones. So let's try to use this to solve some problems. First question up here presents 12.23 moles of KNO3, potassium nitrate, and I would like to know how many grams that is. So we try to follow our system. First step is take what you're given with its unit and put it over 1. Step 2, draw my brackets, put the unit to eliminate on the bottom, which will be mole KNO3, and then place desired unit on top. Well, I'm looking for grams, and here's where I use my chart. I started at moles, I'm trying to get to grams. If they are 1 step away, we can do that in 1 bracket. Moles is next to grams, that means we can go from grams of KNO3 to moles in 1 step. Now it's about placing in the correct conversion factor. Remember, anytime we're going from grams to moles, 1 always goes with moles, and then we go to the periodic table to get the grams. So to get the grams of KNO3 in 1 mole, we have to add those up off the table. So we're going to take 1K, which is 39.10, plus 1N, which is 14.01, plus 3 times oxygen, which will be 3 times 16. That gets us a grand total of 101.11 grams KNO3. Remember, off the periodic table, you always go 2 places past. From here, it's just a matter of watching my units in my sig figs. Moles cancels, leaving me with grams of KNO3. I do my math, which will be 12.23 times 101.11. My calculator says 1236.5753. Now we have to watch our sig figs. 12.23 has 4, 101.11 has 5. I get 4 in my answer. So, does a 1 count? Yes. 2, yes. 3, yes. 6, yes. There are my 4. First number after is a 5, so we check if there's anything after. There is. If there's something after, the 6 will round up, so we will have 1,237 grams KNO3. Little 1-step problem, moles to grams. Second one says 4.276 times 10 to the 26th atoms of calcium equals, question mark, moles of calcium. If we take a look at this, we're going to try to do the same thing. Start with what we're given. Put it over 1. Draw our brackets. Unit to get rid of on the bottom, which in our case is atoms, Ca. Desired unit on top, moles. So we go back up to here. This time we start in atoms, and I'm trying to go to moles. Those two things are right next to each other. So if they're right next to each other, that means that I can do it in one step. Now it's about placing in the correct conversion factor. If we do that, moles always gets a 1. And the number of atoms in 1 mole of anything is always Avogadro's number. 6.022 times 10 to the 23rd. Now it's about doing the math and the sig figs. Atoms cancel, leaving me with moles of Ca. I take 4.276 second E26 divided by 6.022 second E23. And my calculator says 710.063102. Sig figs to finish out the problem. 4 here. 4 here means I get 4. 7 yes, 1 yes, 0 yes, 0 yes. Right, so there are my 4. The first number after the 0 is a 6, which means it will round up. So that means we have 710.1 moles of calcium. So anytime you're trying to go from moles to atoms or moles to molecules, you always use Avogadro's number. Third problem over here, right, is taking 472.49 grams of Ba3BO32, which is called barium borate, and converting it into moles of barium borate. So we're going to try to do the same thing here. Right? Take a look. You've got the number you're given. Draw your brackets. Unit to eliminate on the bottom, which is grams. Ba3BO32. And what we want on top, which is moles. So, back over to here. I started in grams. I want moles. They're right next to each other. So again, this will just be a one step. One always goes with moles. And here's the tricky part of this problem. We need to take the compound Ba3 parentheses BO3 parentheses 2 and add up their numbers to get the molar mass that I can put next to grams. This is a little bit more of a tricky one, so I want to walk through it specifically. If you take a look, the 2 outside the parentheses, just like math class, will distribute in. So the 2 will distribute into the 3 and to the 1 of the B. It will not make it out to this. So when I figure out how many of each atom I have barium, I have boron, I have oxygen. Now I'll take their numbers off the table times how many of them that there are. Barium off the table is 137.3. To get a little more specific, let's look at a table that has it 2 places past. If I can find it. And that means it's 137.33 times the number of barium atoms, which is 3. Boron is next. Boron's number is 10.81. And the number of borons that we have is going to be 2 times the 1, so we have 2 boron atoms. Last but not least is oxygen. Oxygen we know is 16.00, and you have to be careful here because you have 2 times the 3 oxygens, which means we have 6. Now we can take all of those and add them up. So I'm going to take my 137.33 times 2 plus 10.81 times 2 plus 16 times 6. When I do that, I get a number of 392.28. So you have to break that down to get yourself the value. From here out, it's just a math problem. So we take our 472.49 divided by 392.28. My calculator says 1.20447. Grams cancel, leaving us with moles. And we're going to erase this just to get some space. And last but not least, we take care of our sig figs. 5 here, 5 here. It means I get 5 in my number, so yes, 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 yes. There's my 5. 7 will round the 4 up, so the final answer, 1.2045 mole Ba3BO32. Last but not least, we've got 37.92 grams CaCl2 going to molecules of CaCl2. Notice, because this is not an element, calcium chloride is a compound, we never get atoms of compounds. Right? We have atoms of elements, we have molecules of compounds. We're going to try to attack this the same way though. Start with what we're given, 37.92 grams CaCl2. Draw your brackets, unit to eliminate on the bottom, grams CaCl2. We see what we're trying to do. I'm trying to go from grams to molecules. That cannot happen in one step because they're more than one space away. So I'm going to have to do it in 2 steps. What should I turn it into in the first bracket is what's in between them. I should turn it into moles. And then in my second step, I try again. Mole CaCl2 on the bottom, and then grams molecules CaCl2. Because moles and molecules are one step away. Now it's just filling in brackets. Right? Moles always gets a 1. Right? Moles to grams, we always add up off the periodic table. So I have to take Ca, which is 40.08, plus 2 times Cl, which is 35.45, and I get 110.98 for my grams. And then moles to molecules is the same as moles to atoms, even though it's a different unit, the conversion is the same. We use Avogadro's number, 6.022 times 10 to the 20. Finishing up, grams cancels, moles cancel, leaving me with molecules, CaCl2, and now we do the math. 37.92 divided by 110.98 times 6.022 second E23. Right, my calculator says 2.05716 times 10 to the 23rd. We have 4 sig figs here, 5 sig figs here, 4 here, so 4 in my answer. 2 yes, 0 yes, 5 yes, 7 yes. There are my 4. There's a 6 after the 7, so we have to say 2.058 times 10 to the 23rd molecules. And do not forget your exponent, it's really important. The difference between this being 2.058 and 2058 with 20 zeros after it, right? So that's actually a really, really large number. Right? You have to make sure the exponent is there, otherwise you drastically shrink the value of that. I hope this helps you with your conversions. If you're having any questions, please come in for some help.